Hi, good evening, friends. Very good evening. Welcome to the session on Saturday. So this is our 11th day, right? So welcome to 11th day of our session. We will get started. Okay. Let me share my screen. Any questions so far, guys, on anything before we begin? All good so far? Or let me know if you have any questions. If you want me to repeat any concept, we'll do that. No question? Okay, great. If there are no questions, that's great. We will get started. Okay. I hope my screen is visible now. Okay. Not yet. Okay. Now it should be visible, right? My screen should be visible. Okay. So welcome. This is our day 11. Okay. And today is 27th August 2022. Okay. Okay. So yesterday we were talking about set, right? We were talking about set. The purpose of set, okay, is to store values, okay, but it does not mean that it should have any particular order, okay. Set does not have any particular order. That's what we saw, correct? Because when we say set has values, okay, 10 values, okay, so it just means 10 values. It doesn't mean that, this is first or second. For example, okay, if I tell you write 10 states of India, right? So when I say 10 states of India, okay, it okay, so you don't it doesn't mean that we have to write in a particular order, right? Does not mean that this state is number one or this state is number two, right? You can choose to say any state first, isn't it? I said name any 10 states. So you will name 10 states, but not in any particular order. When we define tuple or list, there is the order, like this is first, this is second, this is third, so on, right? But here it does not mean that there has to be particular order. Okay, so that's the difference between list and a set. There is no particular order. Okay, so that's why there's nothing called index here. Okay, so let me define. Okay, and let me define a set values. I'm going to say set 1 equal to, okay, you have curly braces, isn't it? So curly braces 1, 3, 5, 7, 9, 11, right? And then you have set 2, which is curly braces, okay, say 7, 9, 11, 13, and 15. Okay, these are the values in set 2. Now I want to know what are the common values between them. Okay, so let's say question is to enter some number. Okay, so you have entered 13579 and I have entered 7911, 1315. So what is the common number between them? Right? So when I ask what is the common number between them, it is same as asking the intersection, isn't it? In mathematics, you would have all done intersection, right? So it is like asking intersection, isn't it? So the way you handle intersection is, okay, I can do print here, okay. Set 1, okay, ampersand sign, set 2. This is intersection. Okay, so when you run it, yeah, first it takes some time. So when you run it, you will get common number between them, right? Okay. Now I want to know what are the union. Okay. So how do I define union? Okay, so there is an error here. What is the error? Oops, I didn't want to give two space here. How did we get space? Okay. So it says that 9, 11 and 7. 7, 9, 11. These are the common numbers. Okay. So you see here, though we have said 7, 9, 11, okay, it is not giving in any particular order. You get 9, 11 and 7 at the last. Okay. That's how actually the set is. There is no particular order. You cannot say that 7 is first number or 9 is last number. That's why we are getting it this way. Okay. So intersection means common elements between the set, right? That's what we get. Common elements between the sets. You also have, okay, you also have set 1 union set 2. So print set 1 dot, okay, dot intersection. Okay, sorry, we're talking about intersection first. Well, let's finish intersection, then we'll talk about union. Intersection set 2. Okay, now when you run it, okay, see, you get two output. The first one is coming from the ampersand, right? And second one is coming from dot intersection function. So you can find intersection using the ampersand and sign, or also using intersection. Okay, great. Now the next one is called union. Union means find all the values. Okay, so between set 1 and set 2, between set 1 and set 2, what are the common values? Simple. So print, one option is you say set 1, okay, and then you use pipe sign. Set 2. This is going to give us the common elements between set 1 and set 2. Okay, or you can also use union function, which is the union function set 1, okay, set 1 dot union, and you say set 2. Okay, you run it. Okay, it is going to give us same value, right? Okay, and you see that when you're talking about the common elements, okay, yesterday we saw that set will remove the duplicate, right? So if I tell you enter 5 or name 10 states of India, you cannot say Andhra, Andhra, Andhra 10 times. Okay, Andhra Pradesh is just one state, isn't it? So here we mean that it is one state. okay, one value. So even if it is duplicated, it is taken as one value only. Okay, make sense? Okay. Then you have next one, which is called as, okay, say difference. Okay, so we have symmetric difference and difference. Okay, difference, and you have symmetric difference. There is a difference between difference and symmetric difference. Okay, what is the difference? Okay, in difference, okay, so if I say print set 1 minus set 2, okay, this is a difference, minus sign. If you use minus sign, this is called difference, simple difference. Okay, or you can also use the function, which is set 1 dot difference set 2, and you run it. Okay, now what happened? Okay, so you see that difference set 1 minus set 2, this is our set 1. From set 1, remove the elements which are in set 2 also. So this is set 1. Is 7 in set 1? Yes. So remove 7. 9 1 set 1? Yes. Remove 9. 11 is in set 1? Yes, it is in set 1. Remove. So 7, 9, 11 will be removed. 11, 13, 15 is not there. So no, no action there. Right? So that's how, we use difference. Okay. So you can see that. Okay. Okay, let me here, let's do set 2 minus set 1. Okay, better. Okay, so when you do set 1 minus set 2, the elements which are not there in set 2 are printed. So 135 is not there in set 2, so you have 135. Now when you do set 2 minus set 1 or set 2 dot difference set 1, isn't it? When you do this, then okay, you get 13, 15, because now we are looking for elements which are in set 2. So 135 is not there, so no action. 7, 9, 11, remove 7, 9, 11, and you will be left with only 13 and 15. That's how when we do this one, we are getting 13 and 11. Make sense? Everyone with me? Okay. So this is how it works. Okay, difference. Now, what is symmetric difference then? Okay, so how do we do symmetric difference? We do print set 1, this 6, okay, set 2, or you say print set 1 dot symmetric, okay, symmetric difference, you see, set 2. Okay, now you're running. Now see, difference set 1 minus set 2 is not same as set 2 minus set 1. Okay, set 1 minus set 2 is different, and of course set 2 minus set 1 is different. But symmetric difference, okay, set 1 my symmetric difference set 2, let me put set 2 here, better we can see the difference. Okay, it will give us the same result. It is not going to give us different result, same result. Okay, so symmetric difference is like doing set 1 minus set 2 and set 2 minus set 1, and then you do the union. You are performing both differences. You are performing both the differences. Okay. What are the differences? Differences is, okay, it's like, it is same as, right? Same as union of, okay, set 1 minus set 2 and what happened? Set 2 and set 2 minus set 1. So find this and club them together. That's what symmetric difference is. And symmetric difference is symmetric. That means set 1 symmetric difference set 2 or set 2 symmetric difference set 1. Answer will be same. Answer will be same. Okay, great. So, okay, so these are functions. Now, all these functions, if you see, is returning us third set. All the above operations that we have done are returning us third set, right? So whether you're doing union, intersection, difference, or symmetric difference, it's returning third set. Now we have functions like update. Okay, you have intersection update. Okay, you have difference update. You have symmetric difference update. So what this all update is doing? What all this update is doing is, it is like saying set 1 equal to set 1, okay, union set 2. Okay. Okay, set 1 equal to set 1 intersection set 2. So it is not returning us new set. It is updating the existing set only. It is updating the existing set only. Okay, this is like doing set 1 minus set 2. Okay, and set 1 symmetric difference, right? So this. Okay, this is how we use. So to operate, if I say print set 1 dot update. Update means union update. Okay, update, you can say it's like union update. Set 1 dot update set 2. Okay, now if I print it, okay, now let me put some print statement indicating talking about, or can say working with update functions. Update methods. Okay, now let's run this and see. Okay, see, it is returning none. So this is not giving us a third set, right? Yesterday also we saw a couple of examples. Okay, like sort. When I say set 1 dot sort, it is not returning a new set value. Set 1 dot reverse. Okay, it's not returning new set. List 1 dot reverse or list 1 dot sort is not returning new list. Similarly, set 1 dot update is not returning us new set. Instead, okay, you can say set 1 update set 2 here, and then you print set 1. Set 1, sorry, not set, sorry. Set 1, right? So set 1 value itself is changed here. See, our set 1 is only up to 11. Correct? Only up to 11. But we got the set 1 is only up to 11, right? 7, 9, 11. But 13 and 15 also got added to set 1. So if you want to create a new set, you have to say, you don't have to say update, right? You just have to say union or intersection or symmetric difference or difference. But if you want existing set to change its value, if you want set 1 to change its value, then you will say update, okay? Or you can say, okay, you can say set 1 dot intersection update. Okay, you can say set 1 dot difference update. Set 2 is not changing, okay, but since we are applying the method of set 1 value is changing. Okay, so set 1 dot difference update. Okay, sorry, symmetric difference update I meant. Difference update we have already done. Symmetric difference update. Set 2. Okay, so these will change the value of set 1 itself. Okay, now let's see what's the value of set 1 after performing all these. Okay, this is what we get. Okay, so the point I'm trying to make here is that set 1 itself is changing its value. Okay, unlike the other examples that we have done so far, it is returning. Okay, so operation on set 1 and set 2 is returning new set, but here it is returning, it is updating the set 1 itself. Right. Okay, so this is it. Okay, there are a couple of more functions that I want to show you. Okay, you have each superset, each subset. Okay, you have remove and pop. So let's say, okay, so this is our set 1, right? So let's say we create another set 1 equal to this. Okay, oops. Okay, now I want to perform print set 1 dot pop. Now pop will not take any value. Okay, pop is removing, okay, by element by itself. Okay, pop will remove, okay, any element by itself. Okay, so now if you, okay, any value is removed. Okay, so when you say set 1, so 7 is gone, right? It's removing 7. So now 7 will be gone from set 1. Okay, 7 is not there here. See, now you have something called as remove. Remove dot, sorry, set 1 dot remove. Here it needs, we need to pass the value. Let's say I want to remove 15. Okay, so when you run this, okay, it doesn't return anything, but now when you print it here, set 1, 15 is gone. Doesn't return. Okay, above method returns the value removed or popped, right? And then you have this will not have 50. Okay, so this is how your remove and pop works. Okay, now I'll talk about this joint. Okay, so say I have set 1 equal to, that is 7, 11, 13, 15, and I put set 2 equal to 100, 200, and 300. Now, I want to check if set 1 and set 2 have any common element between them. If they are not common, the sets are not joined. If they have common, that's when we say sets are joined. So print, okay, if I say set 1, okay, dot is disjoint. Is it disjoint in this case? What do you guess? It is disjoint, right? There is no element between them. So answer is true. It is disjoint. Okay. So you will get answer as true. Okay. They are disjoint, isn't it? So yes, they are disjoint. Okay. And if I make this as, let's say, I add, okay, if I add 7, 11, now they are no, right? It is false because they are not disjoint. There are two elements common between them, 7 and 11. There are two elements common between them. So it is false in this case. Okay. Superset and subset. So if you say a set 1 equal to 1, 3, 5, 7, 9, and I have set 2, okay, which has 3, 5, 7. Now see here, all the elements of set 2 belongs to set 1. So this is called subset. If all the elements, okay, so we say subset of set 1. Okay, subset of set 1. All the elements, okay, of set 2 belongs in set 1. It's called subset. This is called superset. That means it has all the elements of set 2. Superset of set 2. Okay, that's what superset means. So in this case, yes. So if I say print set 1 dot superset of set 2, answer would be yes. Okay, this is superset. Set 1 is superset. Oh, there's an error here. Set. Okay, sorry. We're asking question, right? So it is superset. Okay, my mistake. It is superset. Okay, we're asking question, isn't it? Is S1 superset of S2? Answer is yes. It is superset. Similarly, print set 2 dot is subset, right? So see, is subset of set 1. Answer is yes. Set 2 is subset of set 1. Okay. So these are the functions we have on set 1. And we saw that set can be converted to list, list can be converted to tuple, tuple can be converted to set, set can be converted to tuple, tuple can be converted to set, list can be converted to set. All these three things are interchangeable. You can convert list to tuple, tuple to set, set to tuple, tuple to list, list to set, set to list. All these are possible. Okay, with that we finish our set theory also. Okay, so please practice. Okay, there is no substitute for practice. Your programming is exactly same as mathematics. When you see the problem, you will understand it. Okay, but when you are performing, when you are working on it, that's when you will face problem. Okay, so please practice as much as possible, okay, to become expert. Okay, great. So now we will move to next topic, which is called functions. We'll move to next topic, functions. Okay. What is a function? In crude way, function is nothing but it's a set of commands, set of lines of code that you write together and give it a name. So let's say I want to say print hello, print how are you, print where are you. Okay, so let's say I have these three lines of code and I want to repeat it multiple places. So what I'll do is I will put them in a function. Function my func1. So function starts with first defining. Okay, so when I said function means some lines of code together, so you have to define function by a name, right? So function by a name, and then inside that we have to write all the lines of code that we want to define for a function. So in this case, I'm defining a function called def my function name. I have to give name to the function. So I'm saying def my func1 bracket open and close colon. Def my func bracket open and close colon, and then you give the indentation and you put all the lines of code that you want to be part of this function. So I have these three lines of code which I want to be part of this function. Okay, I want these three lines of code which I want to be part of this function, and I want to give this function a name called my func1. So def, short form for definition. So we are defining a function here. Okay, we are defining a function here. Okay, so now when I run it, okay, what do you get any output? No, you won't get any output. There's no output because we have defined it. We are telling it that my func1 is this. Okay, so similarly, print is called inbuilt function. Print is inbuilt function because print has some code associated. But when we run it, is print called automatically? No, print is not called automatically. Input another function which is inbuilt. It has some set of code written. But when we call it, is input called automatically? No, input is not called automatically. So all so just like input inbuilt function like input and print, I've also defined my own function. This is called as user defined function. User defined function, UDF. Okay, so this is user defined function. As a user, I have defined this function. These are not inbuilt, which comes pre-installed with Python. Okay, input, print, these are predefined functions which comes with Python installation. Okay, this is my own function. Okay, my func1 is my own function which is not predefined. Okay, now when I define it, nothing happens. Okay, if in fact the program doesn't even go and run this. When is this run? Okay, they're not going to go and check inside what is happening. Okay, they're not going to check what is happening inside. Okay, so they are run when we call them. Just like when we call print input, we can call our own function here. So this is function definition, right? That's what we said, right? This is function definition. Now I'm going to call my function. Now I am calling my function, or you can say calling user defined function. Okay, we are calling user defined function. Say colon and say my func1, my func1. Okay, and you run it. Okay, so whatever we have defined under function is getting called here. That is the beauty of function. And not only that, I want to call, so I want to say, I want to write some command, print. Okay, now let's go for second time. Okay, I'm calling second time. My func1, print. Good. Now call third time, right? No problem. We can call it third time, my func1. Okay, so we are calling this function multiple times, 3 times in fact. You write it once, call it, use it multiple times. Beauty. You write it once and call it whenever, wherever you want to call. So now when I run it, okay, if you see down, so see, this is our first call, this is our second call, and this is our third call. You can call it multiple times. Right? This is how you write a function and you call a function. Okay, so function can have return values or no return values. Okay, function can have return values or no return values. But before that, you see, I'm defining my function in line number 1 here, isn't it? I cannot call it before line number 1. If I try to call, this is just like variable. So if you are putting a variable, you are declaring a variable, let's say variable var1 equal to 10 in line number 5. You cannot call var1 before line number 5. You can only call after line number 5. So here, my func1 is defined in line number 4. So if I try to call here my func1, okay, what happens? It always giving error, right? It is giving error. Okay, so you cannot call my func1 before defining. You should always call after defining. Okay, so this is one. Then okay, so I was talking about, okay, I was talking about return value and no return value, right? So I'm going to call my func1 and then I'm going to call my func2. Okay, my func1 and my func2. Okay, so I'm going to say hello to, how are you to, right? Just to see that we are calling. Now this has no return value, right? So we are saying that we are not putting return in above function or my func1. Let's say here I put return 100. Okay, so here I'm going to say above function is returning 100. Okay, so now when I call here, okay, my func1, okay, that's 2 times is enough. I'm going to delete it. So let's say I'm saying print my func1. So this is what happens. Okay, you know, in the examples that we have done in list, tuple, and even set today, so like when a function returns something, it is printed. Okay, whatever return value is, we can print it here. But if it does not return anything, then it will print none. Okay, so my func1, and I'm saying my func2. So I'm going to print 2 functions here, right? So let's run this. Okay, so see here, my func1 is calling all the values. Okay. And it is printing none. What is this none? Okay. Since my func1 doesn't return, it prints none. Okay. This none, you see, this none is coming from my func1 because my func1 is not returning anything. Sorry. You see, my func1 is not returning anything. Okay. And here in my func2, I'm returning 100. So see, 100 is printed here. Since my func2 has 100 return. Okay, so this solves our problem when we do print. Okay, so here if you go, the set example that we did today. Okay, here, right, update. So when we do update, if you print this, this update is not returning anything. Okay, update or intersection update. Okay, these functions does not return anything. These functions does not return anything. So then what happens? When you print it, it prints none. It prints none because it is not returning anything. Okay, and when you do these functions, here we have done print, isn't it? These functions like set2.symmetric difference, set2.difference, they are returning result as a third set. Okay, so when you have a return and when you print that, okay, it will return you the return value. Or if you do not want to print, you can catch the return value. Okay, so in this case, I want to catch the return value, right? My func2 is returning 100, right? So I can catch, I can say return value my func2 equal to my func2. Okay, and now when you print this, okay, okay, and if you want to see the my func1, you can do that as well. Okay, my func1 and my func1, right? Okay, so first one will print 100, second is going to print none, isn't it? Because my func1 doesn't return anything. So you see, it is returning none, 100. Okay, so today we have seen, or in last 20 minutes we have seen how to declare a function. How do you declare a function? We declare a function using def keyword. Def function name, simple bracket open and close. Okay, this is syntax. This is the way it is, right? This is the way it is. Okay, so def function name, bracket open and close, colon. And then with indentation, you can write whatever you want to write in the function. So in this case, the function is defined. Then only after the function is defined, you are supposed to call it. Okay, so you define the function and then you call it afterwards. Okay, second point. Third point is the function, okay, are of two types based on return values. Okay, there are many types of functions. We'll discuss one by one. First type of function is defined based on return value. So if return value exists, it is, you will have return something. If does not exist, you will not have return. So based on return value, we have classified the function with return value, without return value. When you do not have return value and when you try to catch and print, you get none. Okay. And when you have return value, okay, and when you print, you get return value. Okay. So let's write a program. Let's do a program. We'll use different code here, different block. So write a program to input, okay, 3 numbers, okay, and print its sum. Okay. Okay. So input 3 numbers and print its sum. So we'll do it using functions. We'll do it using functions. Okay. So I'm defining my first function, def my addition. Oops. My addition, and I'm going to say here n1 equal to input, enter a number. Okay, and we will convert this into integer. Okay, and I have to do this 3 times, isn't it? Let's do it 3 times. And n1, 3, and now I'm going to say sum equal to n1 plus n2 plus n3. Okay, so this is it. Okay, now we'll write same thing, same logic in function 2. Now here you see in my addition 1, okay, we'll put my addition return something like this. So in this case, when I'm not returning, I will print the sum here itself. Print sum is, okay, and you can say sum. Okay, this does not return, this function does not return anything. Okay, my addition return will not print, it will say return sum. Sum. Same logic, okay, but difference is in terms of return. The first one does not return, second one returns value. Okay, so if you want to call first one, you have no control. Whatever is there in addition has to be done, right? So here you say my addition. But in this case, what I can do is I can say, I can display the result in the way I want to display the result. I can say print addition of 3 numbers is result. Okay, we have added 3 numbers and the result is result. You know, you can customize the output, but in this case you can't customize. Okay, when you call my addition, you get output fixed. You know, the return will be fixed. Sorry, not return, the display value will be fixed. If I enter 3, 4, 5, okay, you say sum is 12, that's it. But in second case, when I enter 5, 4, 3, I can display the output the way I want to. That is the difference between your return function with return and function without return. Function with return, okay, you do the hard work, take the output, and the output can be used customized way. But in the first case, you cannot use in the customized way. You are dependent on the function itself. Okay, so that's the advantage of using the return value and non-return value. So today we have seen function with return value and not return value. Okay, we'll end it here. We want you to, we want you to have enough time for practice. You cannot say that you did not get time for practice. I'm going to end it here for today. Okay, Monday when we meet, we'll talk about functions based on input type. So right now we are not passing any value to the function. So when I say print hello, if I say print, right? So this is a value that I'm passing to the function. Today, what we have seen, we have not passed any value to the function. We are simply calling the function. And calling the function is of two types, with return and without return. Okay. Monday, when we meet, we'll continue our discussion and we'll focus on different types of function based on the input value. Okay. So thanks everyone. Thanks for your time. We'll stop here. Okay. All the code will be updated in next 1 hour. Okay. So please practice. Next week, our third week, and we will actually get into another level. Okay, so every week we are improving or increasing our complexity. We are, going to next level and next level. Okay, what we have done is basic. Okay, please practice this. Next week when we meet, we'll discuss functions. Okay, we'll discuss functions, we'll discuss class and objects. So that might take us 3 to 4 or maybe even 5 days to talk about those things. Okay. So thank you so much for your time. Enjoy your Saturday, enjoy your Sunday, and please take some rest. Please practice and come back with full energy. We are going to discuss advanced topics next week. Okay, functions, class and objects. These are again very important concepts. So when you say someone that I know Python, they expect you to know minimum till class and objects. So when you say that you know Python, this is the minimum thing that they expect up to class and objects. Okay, so we will perform class and objects next week, functions, and then we get into class and objects. Okay, take care. Bye. See you next week. See you on Monday. Bye, everyone.